Hello, again, welcomes. This one is the second practical session on the limit test. Now, today we are focusing on the limit test of sulfate, because in the previous section we see that what is the limit test, how limit test can be performed, and what's the purpose of performing the limit test, and how we can perform the limit test for chloride, and so today we see that the limit test for what we call sulfates, or limit test for sulfate can be performed by using this experiment. So in this experiment we have different apparatus in the glassware for the limit test for sulfate. As we mentioned in the previous experiment also, Nestle cylinder and the glass rod is very important and a common apparatus for this limit test for sulfate. 1 ml bulb pipette and 2 ml graduate pipette can also be used. 5 ml 5 molarity of acetic acid also used, and sulfate standard solution, which means the 10 ppm sulfate 2 plus minus 2 yes sulfate 2 minus, and test sample barium chloride solution, ethanolic sulfate standard solution almost 10 ppm sulfate ion, and 1 ml graduate pipette can also be used. Actually, this equipment or apparatus and glassware can be maybe changed based on the availability of the equipment in our skill lab. So actually it is not fixed, so you have to modify according to the skill lab. So when you come to the basic principle of limit test for sulfate, this limit test for sulfate is based on the reaction between soluble sulfate with barium chloride in the presence of dilute acetic acid to form barium sulfate, which appears as a solid particle or turbidity in a solution. Have a look at the reaction. This sulfate reacts with barium chloride in the presence of dilute sulfuric acetic acid. They produce what? Barium sulfate, which can be what? Opalescence or turbid plus 2 chloride ion. So the precipitate barium sulfate formed is insoluble in dilute acetic acid and they give opalescence or turbidity, and a known amount of potassium sulfate is added both in the test and the standard in order to increase sensitivity, rapid and complete precipitation by seeding. Therefore, the aim of adding potassium sulfate is simply to increase sensitivity, rapidity and complete precipitation by seeding. So the ethyl alcohol is used to prevent supersaturation and thus producing a uniform opalescence or turbidity. In an earlier edition of the Indian Pharmacopoeia, this ethyl alcohol is added for the purpose of avoiding supersaturation. So actually, so now in the modern Indian Pharmacopoeia, this ethyl alcohol may not be added. So barium sulfate reagent containing a barium sulfate and ethyl alcohol was used instead of ethanolic sulfate standard solution. Then instead of acetic acid, hydrochloric acid was used. The change in the reagent does not affect the objective of the test. So we maybe change the reagent, but changing the reagent does not affect what the results. So the chemical reaction between sulfate plus barium chloride in the presence of acid to produce barium sulfate plus potassium chloride here. So the procedure for test of opalescence is that you have to take 1 ml of 25% weight by volume solution of barium chloride in the Nestle cylinder and add 1.5 ml of ethanol sulfate or ethanolic sulfate standard solution to 10 ml of or 10 ppm sulfate ion. Mix and allow to stand for 1 minute. Then you have to dissolve a given sample in 15 ml of water and add 0.15 ml of 5 molar acetic acid. Pour the solution in Nestle cylinder, and then you have to add sufficient water so as to get 15 ml, and stir immediately with the glass rod and allow to stand for 5 minutes and view it transversely against the black background here. Then when you come to the comparative view of the test and the standard, in case of tests you have to take 2 conical flask or Nestle cylinder. The one is labeled as tests, the other one is labeled as standard. In a test you have to transfer 1 ml of 25% weight by volume solution of barium chloride to the Nestle cylinder and add 1.5 ml of ethanolic sulfate standard solution having 10 ppm sulfate. Mix and allow to stand for 1 minute. Dissolve the given sample in 15 ml of water and add 0.15 ml of 5 molar acetic acid and pour the solution into a cylinder, and you have to dilute to sufficient water so as to get 15 ml. Then finally stir immediately with a glass rod and allow to stand for 5 minutes. When you come to standard solution, transfer 1 ml of 25% weight by volume of solution of barium chloride in a Nestle cylinder. Add 1.5 ml of ethanolic sulfate standard solution. The mix and allow to stand for 1 minute and add 15 ml of sulfate solution and 0.15 ml of 5 molar acetic acid in a cylinder. They have to dilute to sufficient amount of water so as to get 15 ml, and finally stir with a glass rod and allow to stand for 5 minutes. Then after you have to compare what the turbidity that produced in a test sample and the standard solution. When you come to observation, the turbidity produced in the sample solution should not be greater than the standard solution. If the turbidity produced in a sample solution is less than that of standard, the sample will pass the limit test of sulfate and vice versa. So the reason of adding acetic acid help to make the solution acidic, and the potassium sulfate is used to increase what? Sensitivity to the test by giving ionic concentration in the reagent, and the alcohol help to prevent what? Supersaturation here. So this one is the reason behind adding different reagent in the material or the experiment. So how we can prepare the standard or the reagent? So you have to prepare 25% of weight by volume of barium chloride, which means that dissolve 25 gram of barium chloride in 100 ml of water. That means 5 molar acetic acid solution means that any molarity of may be prepared by diluting 57 ml of or 60 gram of glacial acetic acid to 1 liter or 1000 ml of water. That it means. So ethanolic sulfate standard solution can be prepared by dilutes volume of 0.181% of weight by volume of solution of potassium sulfate in ethanol. That means 30% ethanol to produce 100 ml with 30% ethanol. And the sulfate standard solution, you have to prepare 1 ml volume of 0.181% weight by volume of potassium sulfate in distilled water to 100 volume in the same sample. This one is a way how you have to prepare what the reagent for this practical session. So thank you very much. We'll cover other practical skills in upcoming video. So subscribe the channel and press on the bell icon to get the video notification so as to get what interesting video for your future careers. So thank you for watching. Overall, thank you.